All right, so in this video, we're going to talk about extensive properties, intensive properties, states, and processes. So a state is just a macroscopic characteristic of the system. And we'll talk about a couple of properties that you're already familiar with. So temperature, we'll use SI units and English units, so degrees Celsius and degrees Fahrenheit, but we'll also use units of absolute temperature, which you may or may not be familiar with. In SI units, that's Kelvin. It's not degrees Kelvin, it's just Kelvin. And you'll get that by adding 273.15 to the temperature in degrees Celsius. In this class, I'll round off and just add 273. In English units, you would use degrees Rankine. So it's the conversion factor is 459.67 plus the degrees, the temperature in degrees Fahrenheit. But in this class, I always round off to 460. So again, just round off to 273 and 460. And then for pressure in SI units, we'll use kilopascals or bar. And in English units, we'll use PSI, which is pound force per inch squared. And remember that there is a difference between pound mass and pound force, so just be aware of that in this class. I will put a pound force, I'll put an F or an M depending on whether or not I'm talking about pound force or pound mass. And then for volume in SI units, meters cubed. In English units, that might be feet cubed. Speaking of units, this is the conversion factor sheet that I'll give you on exams. So I would encourage you, if you're not comfortable with unit conversions, get comfortable. You're doing a disservice to yourself if you're just Googling, okay, convert this to this. Be able to reason it out using a conversion chart. You're always going to have this table or this conversion factor sheet on your exam. You just need to know how to use it, and it just takes practice. So for 0.5 feet cubed, if I wanted to convert that to inches cubed, you've probably done this in chemistry. Just make sure that the units are going to cancel out. So my conversion factor for feet cubed in inches cubed, I know there's 12 inches and a foot. And you'll notice with my conversion factor here, I've cubed this whole thing up here. So the 12 is cubed as well as the 1. And I just make sure that feet cubed, those cancel out, and I'm left with inches cubed. This one says convert 2,000 foot-pound force to BTU. BTU might be familiar to you, might not be familiar to you. And you probably don't have that conversion factor, 12 inches to 1 foot, you probably know, but this guy, maybe not. So just look on your conversion factor for something that looks kind of useful. Like I looked for BTU. Oh, there's a foot-pound force right there, conversion factor. And again, you're just making sure that that foot-pound force are going to cancel out and you're left with BTU. So if you have any questions about unit conversions, please let me know. Come by office hours. Tons of videos out there on YouTube to look up if you need somebody else to explain it to you in a different way. All right, so properties of a system may be related. So if we know a certain number of them, then we can fix the state of the system. So when we say fix the state of the system, we mean that we'll be able to figure out any other properties that we want to know about that system. And we'll kind of get back to that in a second, but we can classify properties as extensive and intensive properties. And it's the intensive properties that are required to fix the state of the system. So you need a handful of intensive properties. And if you know that handful, and we'll talk about the exact number of those later, but if you know a handful of those intensive properties, that you figure out any other properties that you want to know about that system. All right, so extensive properties and intensive properties. An extensive property is dependent on the size or the mass of the system. An intensive property is independent of the size or the mass of the system. So volume, it seems pretty obvious that that is dependent on the size or the mass of the system. But what might not be obvious is where temperature and pressure fall into that. Is it an extensive or an intensive property? And both of them are actually intensive properties. So let's think about that. If I think about the air in this room and the temperature of the air in this room or the pressure of the air in this room. It doesn't matter whether I'm talking about, I mean, we're not worried about, little pockets of hot air or cool air anywhere. But what we're saying is if I took like just a little bit of chunk of air and I looked at the temperature versus where, I took a bigger chunk of air and looked at the temperature, it's going to be the same temperature. Same with the pressure. So it's independent of how big or the mass of that system. Now, we said before that intensive properties are what is needed to fix the state of the system. So it's important to be able to know as many of those as you can. You can change an extensive property to an intensive property, and in this case, it would be called a specific property. An example that you're going to be familiar with is your specific volume, right? So specific volume would be the extensive property, the volume, divided by the mass, and that would be meters cubed per kilogram. You may be familiar with specific volume, you may not, but it is just the inverse of density. So let's make sure, is that all I've got? Oh, not quite yet. So specific volume is the inverse of density. So rho is equal to 1 over that specific volume. All right. And then a process is how we get from one equilibrium state to another. So this is a process from state 1 to state 2 where we are, let's see, oh, there we go, where we are expanding or we're compressing a gas or a liquid. So this is going from state 1 to state 2. Whoop, there we are at state 2, right? So that would be a process from state 1 to state 2. And yeah, there we go. All right. So hopefully that was clear. Let me know if you do have any questions.